Hello students, this is lesson U2A02. In this lesson, I am going to be transforming the graphs of quadratic equations. So let's take a look. Alright, so there's something called a parent function, and you're going to see me use this terminology again and again throughout this course, because we are going to be performing very, very similar operations to other kinds of parent functions. So for instance, what exactly is a parent function here? So this guy right here, okay, is a parent function for quadratic equations. What do you think this is going to be? This is actually the parent function for linear equations, right? So there are parent functions for different types of equations out there, okay? So right now we're limited to only just these two types of functions that we are like really familiar with, okay? But there are other kinds, and it will be introduced in this course, okay? But understand this right now, that we are talking about parent functions. These are like the most basic forms, okay, of the function. So a parent function for a quadratic equation is simply y equals x squared. The parent function for a linear equation is y equals x. Okay, so with that said, okay, what we're going to do is we're going to perform a series of transformations with this, okay? So let's say I'm presenting to you with the next function over here, with the next equation, y equals to x minus 4 quantity squared, okay? And excuse me for having the stray mark over here. That's not supposed to be there. Okay. And there's another word that I'm throwing in that I am using interchangeably. When I write the word function, or when I use the word function, right now for the time being, okay, just understand that this is an equation, okay? There is a much more detailed definition for what exactly is a function, but again, that's left for another time, another video, okay? So when I say, the function becomes, such and such, I'm saying that the equation, okay, is telling you such and such, okay? So I'm using the word function and equation interchangeably. All right, so with that said, okay, I have the function y equals to x minus 4 squared, okay? And what we're going to do is we're going to compare how this function compares with the parent function, okay? So x minus 4 squared, if you don't know what this is, okay, I encourage you to take out your graphing calculator and punch this into the screen. And you're going to see what happens is all the points that are on the parabola, which I have now in red, what will happen to them is they're going to move, and it's going to be shifted in this manner. So the parabola, okay, will end up looking like this. So you should say, okay, that the parabola moved four units to the right. Okay? All right. And then moving on. So having just seen that x minus 4 quantity squared moved the parent function 4 units to the right, if you were to make an educated guess as to what will happen to this guy, x plus 3 quantity squared, right? If you were to enter this in the calculator, you would see that the points will move 3 units to the left. So the parabola not 4 units, but 3 units to the left. All right. And then moving on, we have the parent function x squared minus 4. Now, how will this compare to the original parent function? Pause the video for a moment and see if you can enter this in the calculator and see what transpires. Okay, and what will happen is these points will get moved 4 units down and look like this. So what we're going to say then is, okay, that the parabola moved 4 units down. And then similarly, in this case right here, okay, if you plot this into the calculator, pause the video for a moment and try and do that. If you plot this into the calculator, what will end up happening is all these points will get shifted up 3 units. And the parabola will end up looking like this. So this will, again, the transformation that took place, we're going to say that the parabola moved 3 units up. So here are the 4 transformations at the moment that we talked about, okay? So we can move the parent function, we can transform the parent function horizontally, and we can transform the parent function vertically, okay? So these are all translations here. If you want to connect this to geometry, you know, what we had talked about in geometry. So these translations, okay, will take place depending upon what you are adding or subtracting, okay, or how you are adding or subtracting from the parent function. You are going to move the parent function either up, down, left, or right. So if you're subtracting a number within the parentheses, you're moving to the right. If you're adding a number within the parentheses, you're moving to the left. If you're adding a number to the overall parent function, you're moving it up. If you're subtracting, you're moving it down. Okay. Moving on. So now we have this scenario where we want to, again, figure out how this will change compared to the original parent function. So enter this into the calculator and see if you can figure that out. So as it turns out, okay, what will become of this is all the coordinates will look like this. So here I have 3, and then the next one is 4, 5, 6, 7, 8, 9, 10, 11, 12. It ends up here. So I have this. So all the y coordinates, okay, end up looking like this. So how would you describe this? Well, this is not a translation whatsoever. We're not moving this left, right, up, or down. What's happening with the parabola is, okay, the parabola is vertically stretched. Or in other words, all the y coordinates are multiplied by 3. All the y coordinates are multiplied by 3. All right, let's take a look at the next scenario. I have y is equal to 1/2 x squared. Graph this into the graphing calculator and see what comes of it. And if you plotted this into the graphing calculator, you should see again the origins. That vertex in the middle there stays where it is. However, these points end up looking like this. So the description here is, okay, what's the result of this? The parabola is compressed, vertically compressed. And what's happening with this, okay, this is the opposite of what happened to the situation here before, from a moment ago, right? However, it can be generalized, right, that both of these are really, really similar. Instead of multiplying by 3, like in the previous situation, all the y-coordinates instead are being multiplied by 1/2. Okay. So there's a vertical compression happening here, and then there's a vertical stretch happening here, okay? So again, the emphasis is on the vertical impact, okay? There is a way to impact this horizontally, okay? However, that's left for another video, okay? At the moment right now, it doesn't make any sense to talk about horizontal impact, at least in this lesson or in this video. Let's take a look at the next scenario. All right, so in this scenario here, we have negative 2x squared, and then I have negative 1/2 x squared. So again, let's focus on this guy first. Pause the video for a moment, see if you can figure this out. So what will end up happening is, okay, all the points will end up in the bottom half of the below the x-axis. So I have 2, 4, 6, 8. So it's right here. And the parabola will look like this. So what's the overall impact? Okay, so because there's a negative there, okay, the parabola is flipped and stretched, vertically stretched. Or another way of thinking about it is, okay, and again, I'm going to copy this because it's very, very similar. You can also think of this as all the y-coordinates, okay, are multiplied by, you guessed it, negative 2. Okay. Next situation, I have y is equal to negative 1/2 x squared. Pause the video, see if you can figure this out. And if you were to guess that it would look something like this, because based on intuition and what happened in the previous example, then you're absolutely right. So the parabola ends up looking like this. So here, I'm just going to copy this because the scenario is very, very similar. So here we don't have a vertical stretch, but instead we have a vertical compression. It's vertically compressed, and all the y-coordinates are multiplied by negative 1/2. And here are all the scenarios. So let's just summarize for a moment, right? If I give you an equation that looked like this, that looked like y is equal to, let's say, negative 3x minus 5 quantity squared plus 4, how would this parabola look different from the parent function, from the parent parabola, from the parent function? Pause the video, see if you can answer that. Well, what would happen here is the parabola y equal x squared will be stretched vertically, will be vertically stretched. Actually, it will be flipped and vertically stretched. Whoops. Can't spell. It will be flipped and vertically stretched, and the vertex, okay, will be shifted 5 to the right and 4 units up. Okay? And then similarly, if I have, let's say, y is equal to 2/3 x plus 3 plus 1, or actually let's do it minus 1. Pause the video to see if you can describe what's happening here. So hopefully you guys had some time to think about this. So the format is going to be really similar to the previous one, although I am going to modify this. So I'm just going to copy down this this right here. The equation, or the y equals x squared, will not be flipped, but instead it will be vertically compressed. So it will be vertically compressed. And it will be shifted 3 units to the left and 1 unit down. Okay? All right, let's try to summarize all the things that we talked about. So what we're going to do is we're going to take a look at this scenario here. So what we've come to, okay, is this culmination of all these ideas, okay? So there, the equation that the format of the equation for the quadratic functions that I've written in the past 2 minutes, okay, took on this form. Well, this is actually called vertex form of a quadratic function. So, what is that? They take on this general format. A times h minus x minus h, quantity squared, plus k. Where h comma k happens to be, you guessed it, it's the vertex. What exactly is the vertex? Well, the vertex is the very, very peak of the parabola. So, for instance, this guy right here, okay, this point right here, okay, is the vertex of the parabola. And where is it? Well, it's located at 4, 0, because h is 4 and k is 0. So, again, the h and k is the vertex. So, another way of thinking about it, yes, h is the x-coordinate of the vertex, but also it happens to be also the axis of symmetry. Think about that. When we talk about axis of symmetry, it's the x value of that vertical line, right? All the x values on that vertical line on that axis is going to be the same. So h, therefore, is in fact the axis of symmetry. And what exactly is the k value then? Depending upon what the circumstances are, k is the y-coordinate of the vertex. That's true. However, it could be the max or the min of the parabola. So it's actually dependent on what the value of a is, right? Because that leading coefficient, a, this guy right here, will determine whether or not we have a right side up or an upside down kind of like parabola. So actually what I'm going to do is I'm going to go down here first. So I have if we have a situation where a is greater than 0, less than 0 rather. I made a mistake. I got this backwards. So it should say this. So if a is greater than 0, whoops. If a is greater than 0, then the parabola is U-shaped, and we call this concave up. Okay, we call that concave up. So U-shaped, the mathematical term for that is concave up. The word U-shape, okay, is not a mathematical term. So when you tell someone, okay, that a curve is concave up, then they understand, oh, it's that U-shape, okay? And similarly, if a happens to be negative, then what happens is the parabola is like an N shape, and we refer to that as being concave down. So if we have a is greater than 0, then that means there's going to be a minimum, right? Because it's U-shaped, there's going to be a lowest point on the parabola. If a is less than 0, that means the parabola is going to be N-shaped, which means we're going to have a max. All right, moving on. So if we have, then this is something new that I have not talked about yet, okay? And this is an absolute value, right? What does this mean? Well, that means whatever number that we throw in for a, let it be positive or negative, okay, it will always turn out to be positive when we take the absolute value of something, right? So for instance, if I say absolute value of -3, this is in fact +3. If I say absolute value of 4, this is going to be 4. Okay, so now with that understanding, what is meant by absolute value of a is greater than 0? So think about this. If absolute value of a is greater than 1, if absolute value of a is greater than 1, what that is telling us is, I'm sorry, I forgot to get rid of this. Okay. If a is the leading coefficient here, right? A is the leading coefficient. So now if a is greater than 1, okay, where the absolute value of a is greater than 1, what does that mean? Well, that means if a is greater than 1 or if a is less than -1. Think about that. If a is -5, right, would the absolute value of -5 be greater than 1? It absolutely would, right? Absolute value of, let's say, 10, is that greater than 1? That is still greater than 1. So if the absolute value of a is greater than 1, in other words, a is greater than 1 or a is less than -1, then what happens is we have a vertical stretch. The y-coordinates will be multiplied by a. Similarly, if absolute value of a is less than 1, what does that mean? Right? Pause the video, see if you can figure that out. If absolute value of a is less than 1, what that implies is, what we end up with is this. A is between -1 and 1. If a is between -1 and 1, okay, then what happens is we again have a vertical compression, okay? It will be compressed. It will be, the whole parabola will be compressed vertically. The y-coordinates of the parabola will all be multiplied by a. All right, so this right here is the summary of what just happened, okay, in this video. And while we're in the process of summarizing, here is the alternate way of writing the equation of a parabola, of a quadratic equation in standard form. That's the equation in standard form. And then there are equations associated with that equation. We can identify what the roots are by using the quadratic formula or by factoring, right? And then the axis symmetry, based on standard form here, it's simply -b/2a. Now you tell me which one is actually easier to figure out, the roots or the axis symmetry. As it turns out, right, if a parabola, if the quadratic equation is written in vertex form, if it's written in vertex form, then it actually is easier to solve for both roots and the axes of symmetry because it's already presented in the problem. So there are definite advantages of writing the equation of a quadratic equation in vertex form over standard form. However, most of the problems that you will be presented with, because this is algebra class, you will be expected to know how to manipulate quadratic equations that are in standard form. All right.